Yeah, we're gonna do 5 together, but you can try to tune me out and go ahead on your own for sure. Now, the thing you want to do first, though, you want to have a calculator out. But the best one, if you don't have a graphing calculator, is to download this app right now. Calculate 84. It is money. It is free. It's almost identical, if not identical, to a graphing calculator. All the same buttons in the same spot. I can press all the same things. Some of the functionality is missing because it can only do so much. But for what we needed to do, it's been great so far. But if you want a graphing calculator, you can just use that. But if you do not, download Calculate 84. It should be one word. It's free. I mean, you gotta use a little data to get it on, but it's a super simple piece of software, so it's very little data. Because what we're always going to do is make those tables. And this way I don't have to plug anything in to my brain. I just plug it into the calculator and let it do what it wants. Right? Because here's the function we're looking at. Y equals 1/3 minus 2? Yeah. And we want to graph that and its inverse. Yeah.
I forgot, when you get the table on the calculator, does the x value have to be under 10?
So I wanted to start at -10 because that's where my graph starts. So like if you look at the graph at the bottom of the page, the x's go from -10 to 10. So I figured I'd just start my table at that first number and see if there's a point there. Because if there is a point -10, 7 or whatever, then I want to plot that one. But if that y value is either too big, 15, 30, 106 or whatever, or it's too negative, right? -13, -60 or whatever, then I just skip it.
Yeah. So both the x and the y value on the table have to be under 10?
Between -10 and 10. Yeah. Okay. So I want my x's and y's to be between -10 and 10, but you can include those because we have that left edge of the graph where we can actually graph. Okay. And so I think that's a really great place to start. Once you get that app, or if you have a graphing calculator, go to y equals, that top right-hand button. I'm going to share my screen home because I've got the graphing calculator emulator that I can at least pull up so you guys can see what I'm talking about. But download that app, man. Calculate 84. I don't know how there's not copyright infringement, or maybe they paid Texas Instruments to help them out. But top left-hand corner, y equals. If you have anything in there, press the clear button to get rid of it. And then just type it in. Now, 1/3, like what's the best way to write 1/3? Use division, right? So 1 divided by 3, like you would. So you type it in the calculator, like 1 divided by 3, and then put the x next to that. Now the x is the button between alpha and stat. So on the top, towards the top, but it says like x, t, kind of looks like a 0. It's actually a Greek letter theta. And then -2. Now there's two like minus looking buttons. One's a minus, one's a negative. All right, we want the subtraction because we're going to subtract 2. That's between the plus and the multiplication on the right. Now, I kind of boxed this in. This is a good place to start. I want to get a nice, really, really nice table of values for x and y. So that's why I actually draw it. I give myself a little tiny little table. I label the top, x and y. But I want to make sure that the calculator gives me all of the possible points that I can fit on my graph. And if you look down at the graph in front of you, the x's go -10 to 10. This is what Margaret was talking about. The y's go -10 to 10. So I want to make sure my points fit. And so I might start my table at -10, not -10, but negative, the one next to the decimal at the bottom. And I want my delta table, I want my table to change by 1s, right? -10, then -9, then -8. I don't want decimal. And so to get to TBL set, that is second window. That's what I'm going to do first. I plug the function in my calculator, then I go second window to TBL set, and I just type in -10 instead of whatever's there. Because as you move your table around, the table start's going to go with it. So, but maybe it's already set to -10, sweet, then you're good to go. And make sure delta table is set to 1. It should already be set to 1. So you don't have to change this one unless you've changed it in the past. That should already be one. And then you press table, but that's second graph. You press the second button first, and then you press graph. And when I look at this table, well, you guys pulled it up yet, but a bunch of decimals, right? Well, it's because of that 1/3, right? 1/3 is 0.33333. So when we multiply numbers by 1/3, we might get some decimals. I don't want any of those in my table. I can't plot them really well. And so if I've got a table that looks like this, I'm only going to write down the nice ones. I'm not going to write down any of the ones that have the decimals. So the -10 with the -5.333, no, I don't like that one. But I do like -9, -5. Both of those numbers are between -10 and 10, and they're really nice. So we never have to write down decimals in the table for these inverses, because I just want to plot nice points. I've done like -8, -7, skip them, right? No good. -6 was good with the -4. -5, no good. -3, 4, no good. -3 was good. X and Y happen to be the same then. I think, right? Hey, what's up there? Now, you get to the bottom, okay, 0, -2, sweet. But you want to keep looking for some more, so I'm going to keep scrolling. Keep pressing that down arrow, you'll see the rest. Because we want to get all the way up to +10 and see if there's some nice ones there, too. Yeah, 3, -1, 6, 0, and 9, 1. All of those. We're just back in that stuff we were working on last week about that. I'm going to stop sharing so you guys can see the board. This is just the same little table right there. So I always start with the table. And here's our plan, right? Make a table for the function. Super easy because the calculator can do it for us. I love that, man. That makes my job so nice. And that Calculate 84 app is the best. Now, there's a couple things. It's still a calculator. It's still got some functionality. If you get stuck, you're not sure what to press, just let me know. I'll walk you through it. There we go. Sweet. There we go. Now, let's get ourselves a table for the inverse. That's all we're doing is inverse functions. Now, I know it's been a little while. I haven't seen you guys since Wednesday in person, but do you recognize the one thing that's missing from that table, Mark? Yeah, nice. That little exponent, not really an exponent, but a little notation that means inverse, right? Inverse notation has that little -1 above the y, so we know what we're doing. See? How do you make that table? Flashbacks to like 5 days ago, I know. What do you mean? Yeah, perfect. Flip them, right? The entire table just gets swapped. All of your y values are now your x's. That's all inverses are. That is all an inverse is. There we go. Switch x and y. So all your y's are now your x's. All your x's are now your y's. And since this equation didn't have any like squares or square roots or cubes or weird stuff going on, it's just going to be a straight line. So all of your points should go in a really nice straight line. And the idea is to connect them in that order. So I'm going to plot them in this order and then connect them in this order. And that'll be one piece, right? So connect what we got 7 points here. So plot these 7 points and then connect them. And then you kind of do the same thing over here. You're going to plot these 7 points. Now I'm just going to graph if you use this one. See it. And so if it's a straight line, obviously use a straight edge. Everything else that's curved will just freehand as best we can. So again, once you have those two tables, plot these points, connect them. Plot these points, if you want to use a different color, plot these points in that second color and connect them. The other thing you want to remember is that because functions and their inverses are symmetric, you want to draw that line of symmetry. That line is always the one that goes top right. Oh, let me change colors. And now what's that? always windows match what you got. Negative 10. Top right, the bottom left. Well, bottom. You know if you're doing it right, if you do kind of like flow nicely. You should see them kind of all line up real nice. And then once everybody has everything graphed, then we'll do the actual. But if you're cruising, keep going. Nice. And so draw that. We're gonna dot that line of symmetry, right? That line of symmetry, I know I'm kind of thinking on the next page. That line is y equals x, and we always dash or dot that line. Because then we can like turn your page and like actually see the symmetry and it looks perfect and beautiful. And as the equations get funkier, the pictures we can make look kind of cool and kind of look like a Rorschach test. Like weird, like ink blots. Looks pretty cool. And it's just because of the symmetry, man. Our brains like it. It makes us happy. Bottom, connect them, extend them. Make sure the arrows are on the ends of both of those lines. And you want to extend them out so that they get to the edge, but you don't want to cross over that next grid line, because if you wanted to cross at negative 10 comma whatever, or whatever negative 6, right? You would have a point there. And so I don't want to cross whatever that next grid line is that I'm kind of aiming for, whatever like flow that line is going to take me. Because this one should go like kind of like that, right? Pretty flat, 1/3, right? Rise over run, rise 1, cross 3, goes up 1 over 3, up 1 over 3. That kind of makes sense, right? Let's see. Up 1 over 3, yeah, up 1 over 3, up 1 over 3. Rise over run. Just some lines, algebra ones. And it should look like that. Look behind you. I'll point you guys to the back just for a second so you can see it. Now this one's a little, like, it's not a square. Like, you're graphing a square picture, rectangle. It's a little stretched out, so it won't quite have the same kind of slope as we built. So it should look something like that. Now my green line is the one that should be dashed. I just can't do that on Desmos, but that's the one that cuts them right down the middle. It goes top right to bottom left. If there are any time for questions about the kind of the graphing part of the tables, now's the time before we get to the algebra. Where's that green line that's coming? So that's the line of symmetry. Every time we graph a function and its inverse at the same time, they're going to be perfectly symmetric. But just not down the middle this way. It's down the middle like diagonal. And so there's a line that's the line y equals x. It goes from top right, let's put an R, top right to bottom left. Oh gosh, I can't. So like if this is my graph, it goes like this. That's right through the middle. And that line is always the line that splits those two like right down the middle. And you can even see like when you look at the picture, like where like the red and the purple meet, right there, that's that -3 spot. It's going to cut right through that too. And what's cool is that once you do it, once you're done, you're doing a good job. What's really nice is like you can tell if you did it right. Turn your page so that dotted line is straight up and down, and you can see this, like it's perfect, right? That thing is perfectly split down the middle. And as these things get kind of funky to look at, You know if you did it right if you just like you can just see it. You don't even have to like do any math. You just like, oh, it looks symmetric. So what's cool about it is it's always the same line. Like you don't have to fix it or do something different. Like as we go from one function to the next, it's always the same line. So that's really like the first three, right? Make an XY table, make the inverse table, sketch the graph, and include that line of symmetry, I'm going to call it, because it's a line, always will be, and it makes things nice and symmetrical. Remember what inverses always come down to. You remember from last week, it's all about just switching x and y. We get tables, that's why the line is y equals x is the line that we're going to split it. Because now that we're ready, I think we're there. Now we actually want to find the inverse of this thing right here. I'm just going to rewrite it so I've got a nice space to work in. And it comes over to here. I know at home you can't see it, but it's the same notes from last time. But how I come up with the actual equation for whatever that, for me, like the purple line right there. And so came up with a pretty easy plan here that works really, really well. How to find inverses algebraically. And the key for us, since I want to actually switch x and y, right? That's the plan every single time. That's what I'm going to do with the algebra too. If it's not y equals, then we got to write it as y equals first. So if they called it f of x or g of x or whatever, then we'll just call it y equals. This one's good though, so I feel good about getting started. I don't know that you have to write it again. I just write it again so I can work straight down. But right away, literally switch them. Y becomes x, and x becomes y. And the moment you get to that red equation right there, you've already found the inverse. Like, look what I wrote into Desmos in the red line. On the left-hand side, I literally wrote that equation right there. Desmos was like, oh, okay, you want the inverse. Cool, I'll just graph it for you. We don't have that luxury on these calculators because the button that we press is y equals. So whatever we're going to do, we've got to get to y equals. We got something we can type in if we want to, right? We're going to solve it. And that's this, right? And just like we always have, we're just going to get that thing by itself however we can, right? This seems to be the easiest, fastest, and safest way to get ourselves to solve it. Take care of any addition subtraction that's on that right side with y, and do the opposite. Then any multiplication division, then any exponents and roots, then grouping, whatever. We just kind of roll through. This one will be pretty simple since we don't even have any exponents. Just have a little -2 and a little times 1/3. So what should we do first? To start getting stuff away from the right side and onto the left. Add 2. Perfect. Look. A little +2, +2. You're going to see the right side's going to get simpler. I'm going to stick with the black so that people at home can see a little bit better. But like the -2 is gone because we have the +2. And as the right side gets simpler, the left side just gets more complicated. A lot of people are like trying to simplify and put stuff together, and that's great, and I love that kind of mindset. But I think the easier kind of, the path of least resistance is to just say, you know what? If my right side is going to get simpler, my left side is going to get more busy, right? More complex. It's like, oh. And I'm just going to write it however I need to write it so that I can read it the same way. Vertically, this says x + 2, right? Then let's write it the same thing horizontally. Not trying to put stuff together, numbers, and those can't even go together anyway. One's an x, the other one isn't. But that's perfect, just like that. Addition and subtraction, done. Right? Just solve for y. That's all I'm going to try to do. Because if I can get a y equals, then there's my inverse. Okay. How's the 1/3 and the y attached to each other right now? Like what's happening in between if I don't write anything? Nice. So how do you undo multiplication? Sweet. Okay. And so if you want to, it's not a terrible idea, divide by whatever the number is. The number just happens to be 1/3, and it's gross, but it's not wrong. But you might feel a little unnerved at the fact that there's a fraction like buried within another fraction, and you're right. I don't like it either. It's got a name. It's called a complex fraction, and we don't like it. And we try to avoid them at all costs. And so as nice as this is, like literally, okay, y equals x plus 2 over 1/3, fine, that's not wrong, you're not going to lose points there. I think there's an easier way to do that. And I just want to show this to you in case you like. So I'm going to do it side by side just so you can see the simpler nature of it. X plus 2 equals 1/3 y. Instead of dividing by a fraction, I want to give you a better choice. I think it's better. But in order for it to make sense right now, I think I got to like take a quick timeout and show you a super simple example of why it works. And it might actually click some memory in your brain of you hearing it before in a different math class. So just real quick. Clear your brain of all that. Just right here. I'm just right here right now. What is 10 divided by 2? 5. Easy question, right? Sweet. Now, 10 divided by 2, right? 2 over 1. Same thing? Still 5, right? But it doesn't really bother me too much when it's written like that. But if I wrote it like this, oh, sorry, divided by, what did I say, 2? Yeah. Divided by 2 over 1, yeah, right? A fraction buried within a fraction. I just don't like the way that looks. I don't like the way that this looks. And so if there was a better way to write this that still gives me an answer of 5, instead of saying 10 divided by 2 over 1, could we take that number that's stuck on top, really can't do much with that. Is there a way to, instead of dividing by 2 over 1, is there something that we could instead multiply by that still gives us 5? Because then it's the same number. Like, what needs to go right here? 10 times something is still going to give me, so look, multiplication, division, right? Same level of order of operations, so they're just opposites of each other. What needs to go in my box, aren't we? Half of 10 is 5, right? And when I say half of something, I really just talk about multiplication. That's okay. Math question, people. So, but that makes sense, right? 10 divided by 2, okay, that's 5, cool. 10, like half of 10, 10 times 1/2, that's 5 also. And so instead of dividing by a fraction, because now I've got fractions within other fractions, maybe we could instead multiply by something else. What did we do from 2 over 1 to 1 over 2?
Sorry?
It's a different number. What do you mean? Close. Close. Closer. So don't think of fancy words. Like, what did you do to this number to get to here? Flipped it. Perfect. What is, now let's get fancy. Because that's all I got to do is I just multiply by the flipped version of the fraction. It's the same. I mean, I can show you 1,000 examples. They're all going to work out the same way. Divide by a fraction. I can multiply by the flipped version of that. What is the fancy math name for the flipped version of a fraction? I'll give you a hint. Good. I love it though. I'll take a chance, right? What's the harm in being wrong? Nothing. R E. No. I like it though. Keep guessing.
Reflection.
No.
Reflect.
No, that's not the right letter. Helpful, I spelled it right. Now you're saying like wreck in your mind. Let's try that one. R-E-C-I. Yeah, nice. There it is. Multiply by the reciprocal. Like, stop dividing by 1/3. Gross. This looks nasty. Don't do that. Instead, take the left side. Take the right side, because I can do it to both. Let's multiply by the flipped version of that. Well, take this number, flip it upside down. What do you get? Which is what? 3. 2. 3 over 1, 3 over 1, sure, but that's just 3, right? I am just multiplying both sides by whatever the reciprocal of that is. And now, cool, 1/3 times 3, 1. Perfect. When you multiply a number by its reciprocal, you always get 1. And that's the number I'm looking for in front of y, right? When I say solve for y, what am I solving for? Solving for 1 y. I just want that number to be 1. Any way I can. Dividing works, so just multiplying by the reciprocal. And then look how much nicer that is. 3 times x plus 2. Rather than x plus 2 divided by 1/3, now I've just got it written like that. And I just like to put the numbers on the left. It just looks a little nicer. Done! Yeah, solve for y. Did it, right? I got y by itself. It's just on the right side. So I like to make the switch. You don't have to, but I like to make the switch to go like this. Put the y on the left, put the stuff on the right, but I'm still missing something. What's missing from this? This is the inverse of what I came from. Yeah. Right? That same inverse notation, whether you put it there or you couldn't stop here. I'm cool. You want to stop right there? You're done. But I like to just go that one step further and try it out.
So if that factor is just 1/4, then you just multiply it by 4 instead of 3.
Exactly. If the fraction was 3/5, you just multiply by 5/3. And I'll just leave it like it would just be 5/3 times whatever. And as unappealing as that is, it's a heck of a lot better than dividing by the 3/5, right? So always, 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 instead of dividing by a fraction, multiply by this. Done. Now this question is completely done, and we're good to go. Cool? Let's do one more. So, what's the opposite of multiplying by 2? Good. Divide both sides by 2. Sweet. All right, let's do, what was that? That was 5, right? Let's do 6. I'm going to get rid of this, so I got some space to work. But that's the idea. I don't know, it's such a nice, fast way to get stuff done instead of having to do the other one. I think we're still y equals, right? Y equals, ooh, this is a crazy one. Negative 3x minus 1 squared minus 1 plus 5. I'm dying. Don't die. My screen time app said I am on my computer 11 hours a day last week. 11 hours a day. So I feel you for sure. All right, let's do it. Table first. Easiest way to start. Go for the table. Now, how do we do that? Calculator. Guaranteed. So fast. I'm going to share my screen again. So jump into your phone or your calculator. Go to that Calculate 84 app if you got it. So what I'm going to do is I'm going to go back to y equals, and I'm going to clear out that equation from the last one. I don't need it. It's gone. So I press clear, which is above that or below the right the arrow button. If you press delete, you're going to just delete like one number or letter or symbol at a time. So it's like you have to go delete over and over again. But this one just clears it all out, and then it's going to type that in exactly as it is. Now it's negative 3. So you got to press the negative that's below the 3 next to the answer. Then 3, and then parentheses, x. Again, that x button is the one next to alpha that says x, t, theta, and n. Now it's minus 1. Now, for the first time today, we've got an x bar. Do you know how to write the squared in there? A couple different ways to do that. So, negative 3, parentheses, x minus 1. There's actually a button that says x squared. Okay, it's to the diagonal of the 7. So, like up and left from the 7, there's a button that says x squared. And that just means, hey, whatever you got, put a squared up there, and then we'll automatically like put the 2 up here and then move you right back down so you can keep typing. The other option, so x squared is a good option. The other option is to press that caret button above the division sign and then press the number 2. Now, there's advantages and disadvantages to both. The problem right now with this second one, now I'm still up in the exponent. Like I'm stuck up at top. You'd have to right arrow out in order to press the +5. So I usually do that though. I usually go like caret 2 and then I right arrow +5. You gotta make sure it's typed in correctly before you can do anything else. Nice. Not yet, because that 2 is just being multiplied through. Now we have to deal with the square. And just like the opposite of squaring something is a square root, opposite of a square root is squaring. So you're going to square both sides. You're gonna like put like parentheses around the left. No, not square root. You're going to square. You're going to create an exponent. It's the one. It's the one next to the alpha that has x and some other letters. And so that watch. This is going to affect it. There you go. Nice. Both sides. You're going to square both sides. And what's going to happen is that like there's your left side. Perfect. Don't change a thing. When you square the right side, the square and the square root. Yeah. Right. Is everybody typed in okay?
I just did it. I almost had it.
I know, it's like so many things. Good. So there's a couple. I like this button. Like if you were on a calculator, it would look more like it was up in the exponent, but that's the extra button. And just +5. Let me show you the other way. You can see it. So, press that little up arrow looking thing right there, move up into the exponent, and then you can type any exponent you want. 2 or 3 or 5, and you type it. So this is 2. The only downside to that is that I'm saying, like if I kept going, if I press +5, I'm still in the exponent. That's not what I want. I want it out of the exponent. So arrow, and moving back down. Either one, whichever one works for you.
Thank you.
Yeah. Now remember, you got to reset your table. So you're starting at -5. Good, Peyton? No, I was doing calculus. We're doing projectile motion, and I just chucked it. No, it was like, hey, watch this, and I just chucked it. Watch the video, man. I record everything. You can hit me with it. It's a good one. I literally just said, hey, watch this, and I threw a pen through the air. Because in calculus, we do projectile motion. We like stop time, and we say how fast is it moving, how fast is it rotating. Love it. Looks good. Yeah. So I'm going back to table set. So second window, because I messed up my table because I scrolled down to 0. And so I go back, and I'm just making it look like this. My table set looks like this. Start -10, go by 1. And then second graph to get to the table. Oh, geez, -10 is huge numbers. -358, 259. Oh, no, I don't like any of those numbers. None of them. So I'm scrolling down. I'm just scrolling until I find something I like. Ooh, I like that one. -1, -7. Right, all the other y values were too big in the negative side. I couldn't fit them in my graph, so I put them in the table. This one's good. This one's good. This one's good. No. So sometimes we have 7, sometimes we have 5 points, whatever fits, right? I think when we did a cubic on Wednesday or Thursday, we only had like 4 points. Okay, and that's just one graph. We'll just connect that. And what's cool is like because we have a graphing calculator, you can just legit press graph. I'm in a weird window. I'm gonna zoom standard. Like it'll show you what the function is gonna look like. Press graph and you will see what you're supposed to get when you plot those points and connect. But before I even do my graphing, I always like to come up with the equation for the inverse first, or the table. Sorry, table for the inverse first. What am I missing before I put in the numbers? Good, right? That little symbol that tells me this is a table for the inverse and nothing else. How do you make it? How do you make the table? Where do the numbers come from?
Oh, you switch them.
Flip flop, perfect. Nice. All my y's are now my x's. All my x's are now my y's. All my x's and x's. There we go. Now we're ready to graph. Remember that song? All my eggs. Is that an old country song? Definitely not true. I don't even know anybody say. All my eggs are living in New York. And that's where I want to keep. That's a different story for a different day when you guys graduated, man. Here we go. Negative 3x minus 1 squared plus 5. That's what that graph should look like. Right, you can, again, you now own a free graphing calculator. It's on your phone. The top right-hand button on that calculator says graph. You can always use that. But if you're in a weird window, if you're not seeing the picture you think you should, press the zoom button and press option number 6. That is zoom standard. That is negative 10 to 10, negative 10 to 10. That's going to give you the exact picture you're looking for. Now, don't trust Desmos too much because the graph you're graphing on is a square. This picture on my computer is a rectangle, and so it stretches it out. So we don't get quite the picture we're hoping for. But what you're looking at home, that is also a rectangle, so this is a little stretched out this way. Now, here's a key though. Lines were easy because you just connect the points in a row. This graph is going to just look a little kind of funky when you connect it. I mean, it's not too bad because they're at -1, -7, 0, 2, 1, 5. And it's going to look like this. And it's pretty easy to say, oh, that's a parabola, it's just upside down. Cool, I feel really good about graphing that. Right? Extend it, throw some arrows. Extend it, throw some arrows on the edge. God, I did not hit that point. Not even close. Just sketching. But when you graph the inverse, and I cannot stress this enough, the order that you write them down in this inverse table is the order you want to plot them. And the order you want to connect them. So if you're going to connect them in this same order that you plotted them in like that, it's going to look something like that. Of course, we've got that line of symmetry. It's not perfect because I'm just sketching up on the board. That line of symmetry will touch through. So it'll kind of have like that sideways heart looking thing. Yeah. Sure. Remember, arrows on your ends. Extend the graph out, right, past that last point, but just don't cross that next grid line. Because if there was supposed to be a point at that Y line or that X line, we would have plotted it. So once you connect the points that are there, and you're like, oh, I'm just not at the edge of my graph yet, right? I'm only at -7. My graph goes all the way to -10. I better keep going. When you extend it out, throw some arrows on the end. Just make sure you stay inside those grid lines. Check. Got it? Easy? Good? Beautiful. Love it. Right? And like just that feeling of being like, all right, you know what I can do? I can take this paper and I can turn it. And as soon as that perfect, where am I looking at this one? Right? As soon as this line is perfectly up and down, you can just see the symmetry. It's so beautiful, so nice. So hard. Well done, Brent. Now the thing we want to do though, Miss M, is not straight, you just reangle. You don't have to worry about like lining up the straight edge and making sure it's all perfect. You just try to connect these. Love it. Nice. Don't forget. Extend the line. The same thing with that one. You just don't want to, the last point is here. I'm not supposed to cross this line, otherwise I'm not. So I just kind of extend it and stay like inside that line. Love it. Looks good. Feel good? Oh, you're improving. Love it. Okay, good. So I'll let you finish up those last couple sketches, and then we'll do it. We will finish up this last one, and then I'll say this now, but I've already put it up on Canvas. This classwork 3.1, initially I had it due today. Initially I had it due like last Thursday. But then I changed it because obviously we couldn't get that done with the snow day, which is fine. I wanted to give you the day off. That's what snow days are for. So. This is not due until tomorrow. But I am going to give you stuff that I'm going to start tomorrow. It's time allowance. Because there are going to be a lot of people that are like, well, I'm done. I did it all. I've got the whole thing done. Now what? And I don't want them to be stuck at home with nothing to do. Here I am walking circles around it. Kennedy's been hoarding that right in front of her the whole time. This is just 3 points. It's just more practice. Like, this is the whole freaking chapter. Like, it's just take a table, make a table, draw some pictures, we'll find it. And so I just wanted to give us a chance for some more practice. And I was trying to map this out as to what it might look like between this week and next week. The thing that I don't really want to do is like start something new like Wednesday before spring break and just come back and like have to reteach it anyway. So I think how I want it to kind of play out is we get to like the end of this week and we've had some chance to work through 3.1 and 3.2. And then we'll do a quiz for effort and completion on Monday, Tuesday. And because this chapter is not all that big, we won't have a big old test. It'll be the same size as the quiz. I'll just call it a test, but it'll just count for a little bit more. Like Wednesday, Thursday, just in class. So like you can, like your day when you're at home, just make sure you're caught up with all the old classwork and you're good. So like you guys sit in front of me, we'll take like, call it like quiz 3A on Monday in class, just like effort and completion, just see how you guys do with like a handful of them. And then same thing on Wednesday, but for and we'll like done. We'll just call it right there. Like there's the end of chapter 3. And we'll just go on spring break with a clear head and just not worry about like having to like remember stuff from before. And then I'll do brand new stuff and get back. Rather than like finishing too fast, not getting enough practice in, or taking too long and then we got to come back and remember how to do it. So, right. Good?
Yeah.
Okay.
Yeah.
Yeah.
Yeah. One, two.
But that looks like you're negative. There it is. You're on. All right, let's finish up with this last part. Let's actually find the equation. Now, you don't have to rewrite it. I just like to, so I've got it right on top. Every single time. What should we do first? That's it. Like that's all it is. If I can just switch X and Y, I'm already on my way to figuring out what's going to work. And this one's a little bit messy because it's got a lot of stuff going on here, but the plan is still the same. I'm just going to do whatever it takes to get Y by itself. Just subtraction first, multiplication, division, then exponents, then I get inside those parentheses and I finish up. All right, so switch X and Y. Again, if it was f of X, I'd have to make this, like call it Y first and then make the switch. And then you're going to see that on classwork 3.2. I get some f of X and some d of X, so we can kind of use that process. We got lots of time, and we got 2 weeks to really kind of nail this down, do really well. And then kind of go from there. So what do you think we should do first? Sounds good. -5 looks good. And I'm just going to stick with the black the whole way, just home can see. And remember, right side is going to get simpler, but the left side is just going to like take all of that in and be more complicated. Like the best way to write x minus 5 is just x minus 5. There's really nothing else I can do there. I can't put anything together, that's for sure. And the right side just gets a little simpler. +5 goes away, but everything else comes down. Addition, subtraction. Okay, now. Do we have any numbers that are being multiplied through that whole right side? Right, nice, right? This right there, that's connected with multiplication right there. So what is that number that's being multiplied through? Nice. We got to bring the negative with us also. Right? The number itself is -3, right? The sign of this is negative. So when I choose to divide, I divide by the negative. Now, I don't have to worry about that whole multiplying by the reciprocal thing. I'm not dividing by a fraction. That's only to avoid those complex fractions. So cool, divide by -3. Whatever happens, happens. Way that goes. You're good. Sharing's caring. I like it. Yeah. I really do. I'm like, put my hand on Oh. I also had slow roasted beef and garlic spinach for lunch, so let's just say it's kind of hot under this mask right now. All right, let's just finish it up. I'm talking too much. Left side looks good. Like, don't change a thing. Whatever it is, it is. Okay, cool. Multiplication division done. We have any exponents? Yeah. What's the opposite of squaring something? Love it. So, what's that? Just don't forget the plus or minus in front of that square root. Plus or minus, like just whatever it is, man. Whatever it is, it is. It's ugly, but it's perfect. Exponents and roots done. Now we get inside the parentheses, all right, inside the grouping. Now we can just deal with the -1 with little +1. Now I like to put the +1 first. I don't need the plus sign in front of it. And then the plus or minus the square root after that. Makes it just look a little bit nicer with the y. Put that little -1 at the top of the y and call it done right there. Or make your brain and my brain a little happier. Put the y on the left, everything else on the right. All right, so that's 5 and 6. Finish 7 and 8 tomorrow. Anything you haven't done. And ask lots of questions, but use that calculator to help. You good to go? We're going to start it tomorrow for anybody that's ready to start. I just wanted you to have it in case you like knock this out and you're like, oh, I get this, let me just do it now. Then you're just ready to go at home tomorrow. You don't have to print anything yourself. That won't be due until probably like Wednesday or Thursday. Yep. Yep, you're welcome. So, Marty, we finished up number 6. You should take a picture of that. Yeah.